Once you have your Spring application deployed, how do you peek inside the running application to see how it's behaving? Check on the health and trigger notifications that will alert you in case something went wrong. For some of these features we'll have to use external tools, but for most it turns out Spring Framework got you covered with Spring Boot Actuator. Actuator in mechanical engineering is a component of a machine that is responsible for monitoring and controlling a machine. That's where the name comes from. In this tutorial we'll go step by step to add observability and metrics capabilities to our existing application. We can export our Spring Boot application metrics and our Postgres database metrics to external system monitoring tool like Prometheus, which we'll also explore in this tutorial. We'll also see how to query metrics data with external analytics application Grafana that will help us visualize current state of our system. Spring Boot Actuator offers production-ready features such as monitoring and metrics, and it does that by providing several endpoints which you can consume over HTTP or through JMX beans. JMX stands for Java Management Extensions. We'll add Spring Boot Starter Actuator dependency to our POM XML. Having done that, we'll have several endpoints available for us under the Actuator root path of our running Spring Boot application. Since we have Spring Security guarding our application, we'll grant access to everyone to Actuator endpoint in order to be able to see what's going on. If we start our application and hit our Actuator endpoint, we'll be greeted with the HATEOS, hypermedia as the engine of our application links, describing what sub-endpoints Actuator has available for us. We see that by default health endpoint is available, and the status of our application is up. We can change the behavior of the actuator by modifying the application properties it offers. Here, I've changed the base path from actuator to management by modifying management endpoints web base path property. In order to see everything actuator has to offer, I've decided to expose all its sub-endpoints by using management endpoints web exposure include property and setting it to star. We can also exclude certain endpoints by using management endpoints web exposure exclude property, which take precedence over include property, so we can combine them. So we can include all and then exclude some. Actuator exposes properties through HTTP, but can also expose properties to JMX, Java Management Extensions. And here I've enabled all the properties for JMX and included them for us to be able to see them. We'll use JConsole application that defaultly ships with Java to inspect the JMX endpoints Actuator exposes for us. In these properties, notice that there are two terms, enabled and exposed. Enabling properties determines whether they will be present at all. Exposure determines whether they will be seen. When I've changed the base path from Actuator to management, I've changed the base path for all sub-endpoints. It's all or nothing proposition. You cannot leave just, let's say, health sub-endpoint under the Actuator base endpoint. You'll remember that in our security configuration, we've permitted everyone to the Actuator endpoint. This would no longer work because we've changed the base path to management. So we don't have to change the property in two places. Instead of hardcoding the name of the base path, Actuator offers endpoint request. And we can say endpoint request to any endpoint, permit all. And this will be smart enough to notice when the base path changes in our application properties and to take that into account. I've restarted our application, and if we hit our management endpoint instead of the actuator, we should see additional endpoints available for us. And we do. We see everything that the actuator has to offer. We can also open JConsole that will have us look at the actuator endpoints through JMX. And we can navigate to mbeans or Spring Framework and see all the endpoints we saw in the HTTP request as well, from beans, caches, environment, health, etc. In the rest of the tutorial we'll concentrate on the REST API, not the JMX. When you look at the REST API, you will think that the actuator exposes its data just as a normal controller, but that's not the case. We saw that we can access its data as a REST API, but as well as the JMX endpoints. That's why the Spring team devised a new term, endpoint, which can send data to multiple things. And in our security configuration, we've used endpoint request to mark that. Later down the line, we'll see we'll be able to contribute to Actuator endpoints with our own custom endpoints by using @endpoint annotation. Let's explore endpoints Actuator offers by default and see the data it provides. Two of the base endpoints are health and info. Health produces an aggregate status of the application and possibly of the external dependent applications. It can have values for status up, down, out of service, or unknown. In our case, the status is up. Info returns developer-defined information about the application. Currently, the endpoint returns no data, but we'll fill it up with our own information in a moment. Next in the line are a couple of endpoints that return information about the application context and the beans available for us and the way they were configured. On beans endpoint, you can get a list of all the beans in your current application context. Conditions endpoint produces a report of auto-configurations conditions that either passed or failed, leading to the beans created in the application contexts. It has three parts, one for positive matches, one for negative, and one for unconditional classes. For instance, we see that the unconditionally configuration properties auto-configuration is placed into application context, and we see a host of negative matches for the technologies we don't use, like Cassandra, Elasticsearch, or MongoDB. As it's possible to have multiple contexts in your application, we have the root of the endpoint as contexts. We only have one in our case. And finally, mappings produces a report of all HTTP mappings and their corresponding handler methods. For instance, we see that our app user controller has post to user signup and that it calls signup method in our class. Similarly, it has patch to user password, it calls change password method. For monitoring the activity in application, Actuator includes three endpoints: thread dump, heap dump, and HTTP trace. Heap dump produces zipped hproof heap dump file that can be used to track down memory or thread issues. Thread dump returns the report of all running threads. The HTTP trace endpoint reports details on the most recent 100 requests handled by the application. Next we have env and loggers endpoint. env endpoint returns the information about the current values of the environment. Values from the env endpoint are by default hidden, because they could contain sensitive information. And we can change that by using property management endpoint env show values. It can be set up to never, always, or when authorized. Loggers produces a list of packages in application along with their effective and configured level. The effective level property gives the effective logging level, which may have been inherited from the parent package or the root level. The possible values for the logging level are off, error, warn, info, debug, and trace. We can get a hold of the current logging level of our package by appending the package name to the loggers endpoint. So for the concatenase package, effective logging level currently is info. To env and loggers endpoint, you can post to change the value of logging level or environment variable, and those values would apply only to appropriate instance to which you posted to, and are temporary and would be lost when the application restarts. If you are using relational database and database migration tools like Liquibase or Flyway, they provide an endpoint with a list of changes that have been migrated to the current database. Another rich endpoint is the metrics endpoint, which can report many metrics produced by the running application, including memory, processor, garbage collection, and HTTP requests. We can also contribute our own application-specific metrics to the metrics endpoint, which we'll do a bit later. We can drill down to a certain metric by appending the metric name to the metrics endpoint. So for instance, for the Tomcat active sessions, we'll append Tomcat sessions active current and get the value of 1. Metrics endpoint is powered by Micrometer library, which is for metrics what SLF4J is for logging, so it enables you to use various monitoring systems by providing a facade, an abstraction, an interface you can interact with and get your metrics to the variety of monitoring systems. Micrometer is JVM based, and it's a low-level library that isn't specific to Spring, and Spring actually depends on, which we can see when we drill down into Spring Boot Starter Actuator dependency. We'll see that it includes Micrometer. And Micrometer can be used outside of the Spring, and in fact it is built into different libraries. Let's see how do we contribute our own information to the Actuator endpoints, and we'll start with Info endpoint. Info endpoint serves to return developer-defined information about the application. Info endpoint will read information from the application properties file as long as we prefix our properties with info. So here I've added properties for our app name and our app links to YouTube and Github. We'll also need to add management property for Spring to be able to read environment variables for info endpoint. Management info and enabled equals to true. Another useful thing we could do is to display build info for our application, which we can do in our already included plugin, Spring Boot Maven plugin, by adding execution section and adding a goal for build info. Since we are using Git as our source code control, another useful thing we could do is to expose git commit information, and we can do that by including git commit ID plugin. If we now rebuild our project, see that in our target directory under classes there is a new file git properties with a host of git information and new build info properties file with the build name, time and version. Our info endpoint should be now able to read all these properties, and if we drill down into it, we'll see that the info provides our app name, links, git and build information. Nice. We can also contribute to the info endpoint programmatically by implementing info contributor. So let's say we want to display total number of our users in the system. We'll create app user info contributor. It needs to implement info contributor, and we'll implement the contribute method. So this needs to be a component in our system, and we'll also annotate it with Lombok value, and we'll use our user entity repository to get the current count of our users. And the way you contribute to the info endpoint is by using builder with details and then build. And we'll need to provide key. We'll say it's app user stats, and then we can provide any object. We'll provide a map of key will be count, and the value will be our user entity repository count. When we restart our app and open our info endpoint, there we see our app user stats count. We have 4 users in our system currently. We can also programmatically contribute to the health endpoint in a similar way by implementing health indicator. Another useful thing we can do in health endpoint is to add aliveness and readiness indicators for situations when we Dockerize our application and use container orchestration platform like Kubernetes. We do that by including health probes in our application properties. Management health probes enabled equals true. Having done that, we'll have additional info in our health endpoint. Liveness is the indicator of whether an application is healthy enough to continue running without being restarted. Readiness, on the other hand, determines whether the application is ready to handle traffic. We can get to the status by appending readiness to the health endpoint. During startup, for instance, an application may need to perform some initialization before it can handle requests, so app will be live but not ready. Let's see how we contribute our own endpoint to the actuator. We'll create a class authorities endpoint. And we'll need to annotate it with the endpoint annotation, which is a special actuator annotation, and provide an ID. Let's say app authorities. We'll also annotate it with components, so it's available as a bean in a Spring application context, and we'll annotate it with Lombok value. We'll use authority entity repository to get a count of our authorities. And we'll need to annotate our method with a special read operation annotation. And we'll return a map of string to long. Let's just say count, and we'll return map of count, and we'll use our repository to get the current count of our authorities. Similarly as read operation, there are also delete and write operation we can implement. When we restart our application and try to refresh our actuator endpoints, we should see a new endpoint, app authorities, there it is. And if we drill down, we see that currently in our system there are 6 authorities. Actuator exposes REST API we can consume and could develop user interface on top of it to easily view actuator data. Community did exactly that. Code-centric developed Spring Boot admin frontend web application that collects and displays actuator data from its clients. In order to use it, we'll create separate Spring Boot admin server application and register our application as client, which we can do explicitly, or admin server can discover applications through Eureka service registry. In order to use Spring Boot admin, I've created a separate application that runs on port 8888 and uses Spring Boot admin server starter. To be able to register our own application that exposes actuator endpoints with a server, I've included server client starter and set property of Spring Boot admin client URL to the server URL of localhost 8888. If we now go to localhost 8888, we'll see our Spring Boot admin. If we go to wallboard, we'll see our application and we'll see the user interface for all the actuator endpoints we were looking at before manually. By including Spring Boot Starter Actuator, we've included Micrometer library for metrics, and Starter also auto-configures Simple Meter Registry, which is a memory metrics store that does not ship data anywhere. /metrics is just a representation of the metrics that is kept in memory. It's up to us to pick which implementation you want the metrics shipped to, and you can pick more than one. Let's say CloudWatch, Prometheus, Datadog, New Relic, Atlas, etc. Micrometer is just a facade. We'll use Prometheus as a monitoring tool we'll expose our metrics to, and we'll explain shortly what Prometheus does. But in order to do that, we'll need to include an additional dependency in our project that exposes our metrics to something Prometheus can consume. When we restart our app and go to our actuator endpoints and refresh, we'll see we have a new endpoint for Prometheus. And before we continue talking about Prometheus, let's just see how we can add our own custom metrics to the metrics endpoint. Micrometer uses meter registry as a main interface to register new metrics and iterate over them and so forth. You can use meter registry in 3 main ways to expose custom metrics, either by exposing it with counters, gauges, which are a metric for something that has top-upper limit, think CPU cores or memory size, and timers, which are a way to time and provide statistics about method execution. So let's use Micrometer and meter registry to time the execution of our change password method. So we'll use meter registry and go to our change password method. Let's say we want to just time the app user service change password part. So we'll use our meter registry and create a new timer, call it change password. And we'll use the timer to record the execution of our app user service change password method. After we restart our application, we can log in with Bob1234 and go to our change password functionality and change it to 9876. And if we go to our management endpoint, to the metrics part, we should see our change password metrics in there, and it is. We can get a hold of the data by appending change password, and we can see it was called once. It has a total and maximum execution time in the statistics of the endpoint. We saw that Actuator endpoints can include sensitive information about our application, and so far we permitted every endpoint to everyone. Now we'd like to change our security configuration and permit info, health and Prometheus endpoints to everyone, and restrict other endpoints Actuator provides to a user that has manage authority. Currently we don't have a user with a manage authority, so I've created new hard-coded user admin that's created when the application starts up, and the password for admin will pass through the application properties environment variable admin pass. When we restart our application, if we try to hit our info endpoint or health endpoint, it is available to everyone, but when we hit our base management Actuator endpoint, we'll be redirected to the login screen, and we'll need to log in with admin in order to be able to access it. And only then we are permitted to all Actuator endpoints. We've chosen Prometheus as a monitoring tool that will collect our metrics, so let's discuss what Prometheus is. Prometheus is a system monitoring tool with time series database that provides instrumentation, metrics collection and storage, and querying and alerting capabilities, and it's meant for all levels of the stack, meaning it can collect metrics from the network, host, up to the service and application levels. What Prometheus is not is a logging or tracing tool. About logging, Prometheus doesn't care about individual events. You'll have to use another tool like Elasticsearch for that. Prometheus only cares about numeric time series metrics. As far as tracing, meaning what path or timings request took through your entire stack, Prometheus doesn't care about that. You'll have to use another tool like Zipkin for that. Typically your application will want all three, so metrics, logging and tracing. Prometheus also doesn't provide automatic anomaly detection, meaning that it will look at your collected data and automatically alert you when something looks odd. It requires you to define explicit, possibly very complex alerting rules. Prometheus also doesn't offer scalable and durable storage. It only has local storage that's not infinitely scalable. Let's look at the architecture of Prometheus server. It consists of three parts. Prometheus has data retrieval worker part, which is responsible for scraping metrics for targets over HTTP. It then stores the data in its time series database and exposes HTTP interface over which we can query the data. We can query Prometheus over its own provided HTTP interface or special clients that understand Prometheus PromQL query language like Grafana and can display graphs. As far as for targets Prometheus can pull data from, they can be our own web applications, like in our Spring Boot example, that we can directly instrument and put metrics on, or they might be stuff that you don't want to put the metrics directly on, like the Linux kernel or the Postgres database. For those we have exporters. Those are little sidecar jobs that you can run next to the things you care about, and they do the translation of the metrics format to the Prometheus format. We already provided Actuator endpoint in our Spring Boot app for Prometheus to consume, but we are also using Postgres database, and in order to collect metrics for it, we'll need to include Postgres exporter. We can also configure Prometheus to calculate the alerts based on collected data. If there are any alerts firing, they will then be sent to a component that we call AlertManager, which does final aggregation and dispatching of alert messages to email, Slack, PagerDuty, and so on. As far as for its data model, Prometheus uses time series database. Time series database is an identifier related to time step value pairs. So the first part is the time step that just goes up, and the second part is the value that can go up or down. Prometheus data model is label-based dimensional data model. That means you have a metric name and then a key value tag pairs attached to that metric. Every unique set of key value pairs gives you one time series. This allows you to track in detail what each metric and time series is about and where it's coming from. To work with this data model, Prometheus introduces its own query language, PromQL, which is a functional-based query language and it's not compatible with SQL. Prometheus has simple graphic interface for executing PromQL queries. Grafana visualization tool has native Prometheus support, so you can just stick in Prometheus data source and use the same PromQL expressions in Grafana. PromQL is also used to do alerting. We define alert name, then provide a PromQL expression that lists a time series and we track them for a defined period of time when they will be pending, after which we send alert to AlertManager component. Let's see all of this in action in our Spring Boot app example. We have a web app that talks to Postgres database. We'll add Prometheus server to collect metrics. We saw that we use Actuator and Micrometer Prometheus extension to expose /Prometheus endpoint, which Prometheus can scrape. We'd also like to collect metrics for Postgres database. For that, we'll have to provide additional exporter service that can translate database stats to something Prometheus understands and provides HTTP endpoint Prometheus can pull data from. We'll then query and visualize data Prometheus collects with Grafana. We'll also define alert if any of our services goes down, which will send notification to AlertManager. We'll use local testing SMTP server Mailhog to receive notification emails. I've mentioned that we'll use Postgres exporter to expose metrics to Prometheus, and a list of exporters and integrations you can find on the official Prometheus site. In there's the Postgres SQL exporter we'll use. Notice that Prometheus has exporters for pretty much every major database, as well as hardware, messaging exporters, storage exporters, HTTP and APIs, logging exporters, etc. In order to showcase our example, I've added monitoring YAML Docker Compose file which will spin up services we talked about. It will spin up Prometheus, Postgres exporter, Grafana, AlertManager and Mailhog. For now, notice that the Postgres exporter defines data source name, which will connect to our Postgres database instance, and we also use Prometheus YAML to define rules for targets Prometheus will scrape. We'll notice that the Prometheus will run on port 9090, and if we have a look at the Prometheus YAML file, we'll see that it has scrape configs, which is a list of services Prometheus will scrape from. It will scrape its own service, it will scrape our Postgres database, and it will scrape our Spring Social to Cloud service. And we provided the management Prometheus endpoint it can get its data from. In Prometheus YAML file, we've also defined a link to our AlertManager component to which Prometheus will send alerts to. If we have a look at Docker PS output, we'll see that we currently have our Postgres database running. And now we'll start our Docker monitoring services with using monitoring YAML file. Once we started our services, we can go to localhost 9090 to open up the Prometheus user interface. We can go to status targets to see the status of our services we are scraping the data from. We can see that our Postgres exporter is up, our application, Spring Boot application, Spring Social to Cloud is up, and our Prometheus itself is up. Our Postgres exporter runs on localhost 9187. And we can see its interface, and we can see that it exposes the metrics endpoint from which the Prometheus scrapes data from. If we go back to the Prometheus interface, we have a graph link where we can issue PromQL queries. The most basic query is up, which lists all our services and gives status 1 or 0 if the service is up or down. And we can issue up equals to 0 to get the list of services that are down. Currently, all the services we track are up. We'll use this up equals to 0 in alerts, in rules, to track whether the service is up or down, and if we do have a service that is down and we'll track that for 1 minute, we'll issue alert to our AlertManager component. If we go back to our configuration, this rule I've defined in alerting rules YAML, and if you have a look at this file, this is the service is down with the expression we track, for how long we track it, and summary of the alert. This is the same information we see in our Prometheus interface, and I've loaded it by default when we started our Docker Compose file. Let's see another basic way to use PromQL queries. Let's say we'll use HTTP server requests by seconds count. We get a list of server requests. We can filter requests we are interested in by using curly braces and giving it, let's say, a job. This is this part will in here. We only have one job, but just to prove a point. And then we can track this series in an interval, let's say, of 5 minutes. And we can track rate of this expression. And we can provide a graph for that as well. This is the basic way you use PromQL. Let's now go to the localhost 3000 where Grafana runs on. And the first thing you need to do when you use Grafana is to define a connection to a data source Grafana can pull data from. I've already defined our Prometheus data source to our localhost 9090. Once you have your data source defined, Grafana also understands PromQL natively, and we can build dashboards. I've already included a couple of dashboards, let's say for JVM, stats, for our Postgres database, and for our Spring Boot metrics. If we go to our Docker Compose file, I've loaded this Grafana graphs and dashboards with definitions from JSON files when the services started. I didn't create these dashboards, they were community given, and that's the power of Grafana. A lot of these dashboards were created and you can just use them if you go to the official Grafana site to the dashboards part. So if we search for Spring Boot, let's say Spring Boot System Monitor, we'll copy the URL, go to the Grafana and import the dashboard by providing the URL and loading it. We'll select Prometheus as data source and import the dashboard. And now we have fourth dashboard. We didn't have to do anything ourselves. If we explore one of these metrics, we'll see that it uses PromQL expression we've used in the Prometheus interface as well. We have two additional services we haven't looked at yet. This is the localhost 9093 AlertManager and Mailhog and localhost 8025. Currently we don't have any mails, and the AlertManager didn't receive any alerts. We saw that we have alert defined in our Prometheus that tracks whether our services are up or down. In case one of our services goes down, the alert will go to pending state and wait for 1 minute. Does the service maybe go up again? If that doesn't happen, if it stays down, it will then fire the alert. Let's stop our Spring Boot application to bring one of the services down. If you go to our Prometheus interface, we'll now see that the state is pending because one of our targets is down. After 1 minute, our alert status went from pending to firing, and the Prometheus fired the alert to AlertManager. If we refresh our Alert Manager, we see that we got the alert from the Prometheus. And if we go to our Mailhawk, we see that we received an email that our service is down. Nice. This concludes our look at the monitoring and metric story for Spring applications. You saw that it's all very coherent and connected story, and all the heavy lifting has been done for us. We just need to use what's already provided.